Hello and welcome to the 1PCC01 mathematics session this week, all about understanding statistics. If you are not aware, then my name is Ian Wilson and this is the digital version of me. I hope you're all looking good and feeling fine. And just before we go any further, can I just say that if you can hear a noise in the background, then I'm afraid it's my floor robot sweeping up. I can't stop him. He has a mind of his own. He's just doing it. The other thing I thought I'm going to do is just get rid of this timer. Bye-bye. Anyway, thank you to everybody who commented that my shirt in the previous video was all shimmering because I had, oh no, touch my face, no. Had a stripy shirt on. So I am now wearing some of my InWills merchandise. Ha! Now you wish you had stuck to the actual shirt. So just so you know, I'm going to record this how I record any video of mine ready in preparation for YouTube. So I will be talking for a while, then stopping it, talking for a while, stopping, so forth and so on. And then you'll be able to pause the video. But if you see just some sly transitions going on, then rest assured, you know, that's what's meant to be happening. Now, I've actually written myself some notes, which I seem to have forgotten. No, I haven't. I've got them. I found them. No worries at all. So, yeah, let me just make sure that I'm saying everything. For those of you who are used to my sessions, you'll be thinking, oh, yeah, this is totally normal. There's no difference from Ian virtually or from real. Okay, then. So, this is the Understanding Statistics session. Statistics used to be called data handling, but it's changed. And we normally give this because if you were going to go into school, they tend to often ask you to do statistical questions with the children. And it's also a golden opportunity to get it into other areas of the curriculum, so geography, science, etc., etc. Now, this video is not going to be 2 hours of you just sat there listening with your feet up with a cup of coffee and a biscuit watching something on the television. No, you will be required to do some activities within these sessions and within this session, and then you will need to upload it to Moodle in an assignment area. Now, before you worry, this is not an assessment. It's just so that if you upload it to assignment area, number one, we can see instantly who's done it and who hasn't done it, but also nobody else can see your work. Okay, only myself and the other tutors can see it, and you, of course. So that's why we're going to use an assignment area. Now, it is fine to sit together and discuss as long as you are appropriate distance apart, but you can, of course, just do this independently. It's completely up to you. Now, if you want to discuss it with people, you know, set up a little chat and then collate your notes together, then that's fine. But please, please, please remember that each person must upload a document. Okay, each person must upload a document. So throughout this video, there'll come a point that there'll be a certain noise, and when that noise happens, that means that you need to go off and do something and pause the video at that place, go off and do something, and then come back when you're ready. Now, just to make this easier, I've got no fancy sound deck or anything like that. Maybe for some other videos I might do that, but for this one I'm just going to go beep, and that'll be your clue, your cue. So you'll need to grab something before we set off. So you need to go and grab something to take notes on. It might be a laptop, it might be a piece of paper. You are going to have to type them up and send them to the assignment area, so you might as well do it straight onto your computer. And the other thing that you will need is a camera of some description. Yes, you're worried now, aren't you? Anyway, go off and get those, and while you're away, also grab, if you can, a protractor, and you might need a calculator, and you might need a compass that you can draw a circle with. Okay, go and do that, grab a cup of tea as well, and then come back and I'll meet you back here. Beep. have you got? No, don't just carry on watching. Go now. Beep. So, welcome back. Welcome back. So we're going to get straight on with the slideshow. The PowerPoint is on Moodle, so if you want to click along, Basil, if you want to click along with that at the same time, then that's absolutely fine. I'm going to try to transition to the screen and not allow the PowerPoint to zoom off the first slide, but we will see. Or is it going to stay where it is? Let's hope so. Pause. Okay then, so here we are. So yeah, understanding statistics. Okay, so previously known as data handling, one of the areas of the national curriculum. And the question is, how do we teach it? What do we need to know about? What's the subject knowledge that we need to know about? How do we bring it all together? So I'm just going to take it to the, panic not, to the next slide. Okay then, so the purpose of today is that we're going to understand the vocabulary associated with statistics and data handling. We're going to understand the data handling cycle. Yes, there is a data handling. Sorry, I just can't get the staff. And we're going to explore the possible activities to complete within topics associated with statistics. Okay then, so first up, I have a question for you. So get ready, pause the video in a second and then answer these in your notes. What are your experiences of data handling or statistics in primary school? So what sort of activities did you do when you were at school, if you can remember back then? Or what have you seen teachers doing? And what have been your own personal thoughts about how this has been done? Write all these down, probably about 3 or 4 sentences, that would be enough, and then come back here once you've done that and we will progress. Beep. Okay then, welcome back. Let's see what theory actually says. So English back in 2006, and all the references, all the links to the references are on at the end of the PowerPoint, actually stated that the problem with most data handling experience by pupils in the primary school is dreadfully dull. Yes, that's exactly what they said. Dreadfully dull. And what Haylock and Cockburn say, I'm sorry, I'm just underneath the Haylock and Cockburn bit. They say that in order for statistics to be exciting, it has to be meaningful, purposeful and cross-curricular. So when they talk about being meaningful, they're meaning that children are familiar with the context of the tasks in which they engage. So it's not something completely away from their basic understanding, like measuring how high volcano spurts out of a lava spurts out of a volcano or something like that. It has to be purposeful. So it has to have a real life purpose to it, or imaginary purpose, and it needs to answer a question. So it needs to answer a question, provide solve a problem, or have some reason for gathering that information. And the idea is that in order to answer the question or solve the problem, children need to gather, come back a bit, I haven't finished, need to gather this information, organize it, communicate it, and then present some information about it. Ideally, it should also be the cross-curricular. So, and that's where a lot of the purpose comes from, and the meaning for it. That it's obviously a lot of the time it comes from something that the children are engaging with in their topics or foundation subjects. Okay then, so we're going to the next slide. So Haylock Cockburn go on to say, this is 2017, in doing the previous, the teacher will plan for the children to be involved in determining what data should be collected, then collecting it, then organizing it, then representing it in some kind of graph, and finally interpreting it. So basically what they're actually saying here is that the children should have quite a large involvement in this. It shouldn't just be a case of you turning up and saying, okay children, today we're going to find out what your favorite color is, go around and do a survey of it. They're saying that there's a lot more to the whole idea of data handling. And it's really important that in order to do this, we sort of like allow the children to see the cycle. So the data handling cycle looks a bit like this, okay? And basically what we're doing is that you specify a problem, you plan for what data you're going to collect, you then collect the data, you then process and represent it, discuss and interpret it, and then answer the specific problem. Okay, so it goes round in this circle, and this is generally what you should be doing all the time with data handling. So the big question is, how does your experience of data handling and statistics relate to theory? So in your notes now, write down a few sentences. Does it match it? Is that what you were normally going to do? Was it totally different from that experience? And if you were taught that way, do you think it would have had any benefits for you? Okay, stop the video there, write your notes down, and then come straight back once you're finished. Catch you soon. Bye. Okay, so hopefully you've added the answer to those questions to your notes. So no, don't touch your face, Ian. Let's continue. So here are some types of data, and I'm giving you 3 different types here. And what I would like you to do is some research now. So rather than just sat there listening to my video, you're going to pause the video again and you're going to go off and find some information. So search the internet, look at Maths is Fun, places like that, look at any books that you've got available, and work out what are the 3 different types of quantitative data. Now these are quantitative, so they're all to do with numbers or number related. Categorical data can involve words. I'll give you that for a starter. Anyway, so 3 types of data: categorical data, discrete data, and continuous data. We've given you a heads up, a starting point, by giving you some ideas, some is statements. But what we would like you to do is go off now, search the internet and try to find the answers to these, and then add these to your notes. Okay, and it'd be really good if you could provide an example that children could use in the classroom. Okay, off you pop. Beep. Okay then, so we're going to move on to some ideas that we've probably experienced before, and I would like you to think whether or not do these actually match to the previous idea of theory. So can you remember right way back in the first year, at the beginning of the first year, beginning of maths, I talked to you about this starting point that we had when with year 6s, I said to them, what colour balloons would you like for your party? So this is a classic example of this data handling cycle. The problem was, what colour balloons would you have for your party? And if you remember what we talked about then, we then allowed the children to decide how they were going to collect the data, how they were going to interact with the data, and then they used the data to provide a solution. And if you remember, with the year 6s, a lot of them even started to do cross-curricular links or thematical links within mathematics, and started to link it to ratios and percentages as well. So this essentially sort of like fitted round that actual data handling cycle. This is another one that we sometimes use, and this is an imaginary one that I've used in the past, and this is when we sort of like say, you know, we're going to get a pet for the classroom. What pet would we have? Now, a nice thing to do about this is to actually use post-its. And if we were actually in the room now, we would all get post-it out and draw on our animal and stick it together, because the wonderful thing about post-it, the wonderful things about post-its is that they're all the same size. And so you can make a block graph just by children drawing their animals onto a post-it, and then it'll make, what I normally do is stick with blue tack a meter rule to the wall, and then put the post-it, stick it on, etc, etc. Oh, we want to go on to Venn diagrams. He's just passing by the door. Okay, so the other good thing about this, if you're interested, is the other thing that you can do is that you can then use that a lot for like a display. Once you've got it set up, you can sort of like get your faithful TA or yourself to take it down from the wall, make a display about it, and then you can even interrogate it. So a block graph, remember, is a graph that is made up of blocks. Okay, so it's actually one post-it on top of the other. A bar chart is when those blocks have been merged together and it's just one long bar. And that's a bar chart. Okay then, so hopefully you can see that these are sort of like link very well to the theoretical side of teaching statistics, rather than what you might have previously experienced. Okay, so next up we are going to talk about Venn diagrams. Have a pause here, have a sip of coffee or tea, and come back when you're ready. Beep. So next up, Venn diagrams. Now Venn diagrams do provide a huge amount of confusion. You might actually have a misconception while we're doing this, so keep that in mind as we go along. Okay then, so let's have a look at this Venn diagram here. So you can see from the diagram that we have just one hoop or one circle. Now the important thing about this hoop or this circle or oval is that it stands for one criterion. Okay, so if we're talking about triangles, then anything that is a triangle will be in the hoop. If there's anything that's not a triangle, it will be outside the hoop. So that circle, it means if you're a triangle, inside; if you're not a triangle, outside. Okay, so if we have a look at this as a sort of like a picture, then we can tell that from this you can see that the circle is a triangle, means triangle, and anything that's not a triangle is outside. So that outside white part is extremely important for a Venn diagram because it's telling me everything that it's not. Now this concept is really, really important. So it's either triangles or not a triangles. Okay, and it's not triangles and circles. It's, if it's in the circle, it's a triangle. If it's outside the circle, it's not a triangle. Now you'll see why this becomes important now, because when we look at the idea of two hoops, okay, now when we have two hoops, each one is a criterion. So the blue hoop, we're going to say that the blue hoop, let's change it a bit. I'm trying to remember what I put on the next slide. Let's say that the blue hoop is a criterion blue. So anything that is blue will be in the hoop. Anything that is not blue will be out of the hoop. And let's say that the red circle is circle or not circle. So anything that will be in the hoop will be a circle. Anything that is out of the hoop will not be a circle. So when we put these two together, we can have something like this. So notice that if I took the red hoop away, we would have the triangle and the circle still in the blue hoop. The reason they're both in there is because they're both blue. Everything else is not blue, so it sits outside the circle. Now notice on the opposite side, that circle is, that sorting hoop is circle, and outside it is not a circle. So notice that we've got the green circle and the blue circle in that hoop. Now if I was to lift that blue circle, the blue Venn diagram hoop off, This is when you suddenly remember that probably using circles and talking about Venn diagram hoops is not a good idea. Anyway, we'll persevere. If you take the blue sorting hoop off, can you see that the two circles will still be in the red Venn diagram hoop because they're both circles? And notice when they overlap, whatever's in the middle then shares both the positive criterion. So they're both blue and circles. Now, one thing you cannot do, and I get quite agitated about this, you cannot say one hoop is everything yellow and one hoop is everything blue, and so when the mixture comes together there will be green. That is not how Venn diagrams work. Okay, so the hoop will be blue or not blue, and the other hoop will be yellow or not yellow. You wouldn't have anything in the middle because you can't have anything that is yellow and blue. And you might be saying, hang on, well, you could have something striped. Okay, if you put something striped in that circle in the intersect and you removed one of the hoop, would it still be in the right place? Yeah, the answer is no, it wouldn't be. So really get your head around Venn diagrams. If you're still confused about it, then do go along to the wonderful maths website, mathsisfun.com, and there's more explanations for you there. Okay then, so this is when you have to do some creativity. I would like you please to draw two Venn diagram hoops and use two different criteria, mark on the different criteria you're using, one for one circle, one for the other circle, and match and put objects in them. Now, you might not be able to do this actually on Word, so if you do it on a piece of paper, then grab out that camera that I told you to have, snap a picture of it, and then import it into your Word document. Show me a wonderful Venn diagram picture. Okay, stop the video here and go off and do it. Beep. So I'm looking forward to seeing all your Venn diagram pictures when I have a look at this work at a later date. Okay then, so before we go any further, I need to talk about Carroll diagrams. And Carroll diagrams are something that comes in about year 2-ish, and you'll either be familiar or not familiar with them. And they actually look like this. Okay, so this is a Venn diagram matrix. So you can see along the top row, we have blue, and then underneath it, we have not blue. And then along the top, we have squares and not squares. So this is like the different areas of a Venn diagram. We're going to have blue squares in the top left, squares that are not blue in the bottom left, shapes that are not squares but blue in the top right, and in the bottom right we're going to have things that are not squares and not blues. Okay, so questions here would be, okay, so what would happen if I changed the color to yellow and not yellow? How would it alter the actual picture? Have a pause here, have a pause, and just make sure that you've got this very clear in your head. Okay, have a pause, have a think about it. You don't need to write anything down, and I'll then come back in a few minutes. Beep. Hello and welcome back. There's been a pause in the recording because I was doing that on Friday and it's now Monday, and I'm going to finish off the presentation for you today so you can carry on and complete your actual session. So where we left it last time, we were talking about, if you remember, Carroll diagrams. And I asked you to go off and have a think about what would change, etc, etc. So what I'm going to do now is that I'm going to continue with the slideshow, and we're going to look at some different forms of graphs. So we've got Carroll diagrams here. So if you remember when we were collecting data on our animals, and I talked about it, look at the little cat peeping up over the top of my picture. And we mentioned blocks. So block graphs are created using blocks. So they can be done by post-its or unifix blocks, and they can be piled up. And generally one block represents one item, one thing. This is a really good starting point for children when they're doing statistics. And if you think back to the structures that we used in subtraction, then you can immediately sort of like see the links with between unifix blocks and difference, and that comparative model. So how many more children liked ducks than they did rabbits, so forth and so on, or how many less children preferred dogs than hamsters, etc. So you can see links now happening to the structures that we taught you. It's all right, I'm finished talking program. Okay, now these are pictograms. Okay, now pictograms are used sort of like further down the school, and basically what we use are little icons or emojis or symbols to represent a certain number of choices. And so you can see in the first one, the pictograms with apples, bananas, pears, that one smiley face represents one child. So this is very similar to the block graph. Now we have to remember with pictograms to make sure that each of the smiley faces, each one of the pictures are exactly the same, both in size and color, etc. Otherwise it might confuse the children. However, have a look at the cupcake one, and I would like you to pause the video in a second and answer the question. So those are the cupcakes, and it says that one cupcake picture equals 6 cupcakes. Now, why might that not be a good choice of image or for that number, etc.? Stop the video now and then come back once you've written down the answer. Beep. So I'm just going to go straight on with this, just so you know. So number one, a lot of the times, especially government figures, tend to use pictograms. That cupcake was really difficult for children to understand. 6, one cupcake representing 6 is very difficult. What would 5 cupcakes look like? Okay, 2 cupcakes look like? How much would one cupcake look like? And if you would it be fair to say, oh, one cupcake is just the cherry on top? Would that actually be realistic? Would that actually be correct? You know, and I think this is why you have to really think about your pictures before you actually decide which ones to use. Okay, let's continue. Let's go to the next slide. So here we have 2 sets of data, and what I would like you to do here is grab your piece of paper again and start to think, what questions would you ask the children about these graphs? Okay, what questions would you actually ask them? And can you notice anything that might be difficult for the children? Are there certain questions that might allow you to identify misconceptions? Okay, so have a look at them, stop the tape, and I'll talk about them in a second. Beep. Okay, so welcome back. Let's have a look at some of them now. So first off, notice the scale, the frequency. F stands for frequency of the dice score one. Notice the scale is going up in 2s, and this is really important, and we need to get the children used to scales having different intervals. And so you can see that luckily all these dice scores had a even number, but if the children were just looking at dice score 2, just looking at them, what would it tell you if a child said that that was rolled 3 times, or the difference between the 1 and the 2 dice score were 2. Can you see what I mean? That comparative model is now a little bit more difficult because of the frequency. Have a look at the 7, 8, 9, 10 one and the frequency there. This one is really, this is a sort of like progression. Oops, no, go back. This is a really difficult one for children because we've gone 5, 10, 15, 20. So where would 7 be? Where would 9 be? And this really allows you to invest in reasoning and providing errors, or saying to children, where would number 7 be, and getting them to change it or explain why they think it would be there. Also, think about scores, 2 graphs about the scales, put different scales on it, and then ask the children what's the same and what's different. Okay, so for example, the dice score, the number of people who liked apples will stay the same, but the bar might get smaller or bigger depending on the scale. And so you can start engaging with that, what's the same and what's different. Okay, moving on. Now it won't move on, of course. Here is one of my favorite interpretation of data, and that's what we're talking about now. And this is the story of bath time, and I would like you to do some work with this yourself. So what I would like you to do is have a look at the graph and talk me through what the story of bath time is. So what happens, what changes the gradient of the slope, what actually happens at that dotted line. Okay, and then write it down, have a think, have a chat about it, keeping social distance, and then I'll come back to it in a second. Beep. So here we are back, here I am, hi. And let me sort of like talk you through some of the ideas. So just to let you know, that red line is when the person sort of like gets into the bath and the level of bath water goes up. A lot of people talk about the top bit, that they fill it up with hot water, then they turn the hot water down a bit, and then they sort of like get the water nice and it's too hot, so they pour a bit of cold water in. The first horizontal sort of like line is when you're sort of like getting undressed, ready to get into the bath water. It goes up, Archimedes principle, as you get in. And then there's that moment, that flat line up at the top when you're just relaxing, you know, with a glass of water and eating a chocolate flake. The interesting thing, and I've done this graph with children, is what that slight down line is. And some people say, oh, the water is too cold, so you turn the hot water on. But would the graph look like that if that was the case? My favourite answer with the children, they either say that they are playing in the bath water, and so water is going off, or they tell me about a thing that they do when they go to the back and go to the front and go to the back and go to the front, and they say, as you do that, Mr. Wilson, the water goes all over the edges and everything, and so you lose some water. Yeah. Then you soak again. You could say that decreases, that you're getting washed and water's going all over there. Then you soak again in all your dirty water, hence why showers are a lot more healthier. And then you suddenly get out and the water level goes down. And it's interesting, should the amount of the distance the water went up on the graph be the same as the distance that's going down? Have you stayed the same, or have you absorbed or drunk so much wine or whatever? Then there's a flat bit when you are getting dried, and then you pull the plug out and the water slowly cascades down the drain. Somebody did once say that the line should go straight down, and we had a really interesting debate about this with the class, in the sense that if the line did go straight down, what would the water actually do? So can you see what we're doing then? You can either go from the physical and say what the graph will look like, or start with the graph and go to what the physical would look like. So you could do it both ways. And we say, yeah, all of a sudden the bath water would be full. You would pull out the plug and it would go, and just disappear in one fell swoop in no time at all. Now you can create your own graphs with this as well, which can be quite interesting. Hang on, I'm going to come back to it. So this is one of my favorite graphs. I use this a lot. And notice that the lines of the graph are there, but there's no axes. So on your sheet of paper, have a think, what could this graph be explaining? What could you put? You could put this on the board for children. What could they say is actually happening? Okay, stop the tape here and then I'll come back with some of my own ideas. Beep. Okay, so welcome back. Let me just cube zoom over to it so you can see it. So a lot of time people say along the x-axis, the horizontal axis, that's time, and the y-axis is, say, for example, distance from home. And this is the trip of a lorry driver, and the lorry driver goes up, and then a certain distance away from home he stops and has a break, so the distance stays the same. Then he travels further, then he has lunch, and then he comes all the way home. Some people have said that this is the concentration in a lecture. So as you sort of like get there, and as the first time goes, your concentration is getting better and better and better. Then you're sort of like keeping it standard and you're really struggling hard. And then at the point when it suddenly zips up again, somebody mentions assignment and you sort of, oh yes, concentrate. And then at the top there, just before it drops, that's about, 10 minutes in an hour and off you go. There was also lots of things that you could do with alcohol level, but I'm not going on into it on this video. Okay then, let's move back one. And let's just talk about this because this is an important one, because this shows a misconception. Okay, so this shows a misconception. So I'm going to ask you to stop it in a second, just have a think about it and write down your answer. The boy walked up the hill, along the top and down again. Okay. Why is that a misconception? What is the child actually doing when they describe the graph like that? Okay, jot it down on your piece of paper and then stop the tape and I'll continue in a second. Beep. Okay, and we are back. Let me just zoom on. So we're doing really well at the moment, and hopefully you're getting a lot out of this lecture. And what we're going to do now is that I'm going to just quickly talk through a bit of the national curriculum with you. So this is a point that you could just relax and listen to my dulcet tones wafting over the internet for you. So remember that you need to refer to the program of study, okay, and you can have a look at it and you can consider how scales and axes discussed within graphical representative relate to specific year groups. So I'm going to do a bit of the work for you here and just point out certain bits for you. So notice in year 2 here, we can interpret and construct simple pictograms. We've talked about that. Tally charts, 4 lines and a strike through. Remember that it doesn't actually matter where the strike through goes, but there has to be 4 lines and then a strike through. Tally charts, block graphs and simple tables, so that's quite easy. Notice it talks about simple questions and it's ask and answer questions about totaling and comparing categorical data. So notice they're comparing, going back to the subtraction difference rule. Okay, moving on, we still talk about interpreting and presenting data using bar charts. So that's when they're no longer the block, they're actually the bar, like we had with the dice score and the ages, pictograms and tables. And they solve 1-step to 2-step problems. So how many more, how many fewer, using the information, looking at scales, etc., etc. Notice down in the non-statutory now, it's talking about using simple scales, for example, 2, 5, 10 units per centimetre. So notice this is relating to the times table as well. And so they're doing a good application of it. I'm going to cough. Don't worry, it's not a new cough or anything like that. Going into year 4, you can see that we're now looking at discrete and continuous data, and we're looking at time graphs. And we're also looking at sum and difference problems. So how many more people like apples and bananas than apricots, so forth and so on. And notice in the non-statutory in year 4, it has a really interesting phrase. It says pupils understand and use a greater range of scales in their representations. It's not giving you any input there. It's just saying greater range, go for it. And notice it also says represent data in recording change over time. Now this is really good to link to your science and starting to look at growth of plants and shadows during the day, length of shadows during the day, etc, etc. Okay, up into year 5, it's really just more of the same. We've got line graphs now which actually show a trend over time, and you can see that they've put in timetables. Notice they also, the non-stats there, they're saying that the work on coordinates relates to line graphs, so they can pinpoint exact points on the graph. And they try to decide which representation of the data are most appropriate and why. Really important. And it goes back to reasoning. And then finally in year 6, something that you might not have seen before. In the old curriculum, in the 1999 curriculum, it said that children had to interpret pie charts. It now in year 6 says that children should interpret and construct pie charts. And we're going to talk about that in a minute. Yes, that's why you needed something to draw a circle with. Notice in the non-stat, it talks about angles, fractions and percentage, linking it to pie charts. So there's the application of that knowledge. And also in the statutory requirement, it says calculate and interpret the mean as an average. Now, just to remind you, and I'm just going to pop my face back on for a moment, just to remind you that there's a bit of a misconception here. There are 3 different types of averages. There's the mean, the mode, and the median. Those are all averages, and the one that we talk about is the mean. Now, we tend to sometimes get really confused about this, and we tend to use the word average and mean interchangeably. That is not the case at all. There are 3 means, and they're means, modes, and medians. Oh, somebody just liked to tweet. Let me turn my mobile phone onto silence. Yeah, so I'm really worried now that Linda's going to get in touch with me and say, you taught everybody wrong. If I have, I'll confess, but that's my understanding of it. Okay, let's just move back to the slideshow here. And so you can see now that we have to, in the non-stats, we have to draw graphs relating to 2 variables, rising from their own inquiry. So this goes back to the data handling module cycle, that they are coming up with the ideas. Okay, now then, let's move on 1 step and 2 questions for you to think about. So you're going to stop the slideshow in a minute and write these down on your piece of paper. So what prior knowledge do children need to create a pie chart? Think about the prior knowledge. What do they actually need to do? Now, at this point, be honest with yourself. If you actually, oh, that's not what I wanted. I wanted this one. If you have no idea how to create a pie chart, then please do some subject knowledge revision now. Okay, and probably in doing that subject knowledge, you'll be able to answer that first question. So what prior knowledge do children need to create a pie chart? So this is very important because we can't get them to do the pie chart unless they've actually got that prior knowledge. And second thing, and my head is just covering over the last word, but I'll do a flip over Zoom. What would be the steps? What would be the steps to success for using a protractor? So think about it. Now, I would like to give you the first one because I would like to say that the first step is actually estimate the angle. Okay, that's the first one. Okay, have a think about it and then come back and I'll give you the answers. Beep. Okay, welcome back. Here we are. This is me again. So, prior knowledge for children to create a pie chart. Okay then, so the first thing that they need to do is to be able to work out fractions of quantities, convert them to percentages of quantities, etc, etc. So if you had 10 results and 6 of them, you need children to understand that that's 6 out of 10, that's like 6/10 as a fraction. You also need them, or 60%. You also need them to relate that to angles in a circle, 360 degrees in that full turn, because the segment that needs to be coloured in will be 6/10 of 360. Okay, and they need to be able to work that out. So fractions of quantities, percentages of quantities. They also need to be able to use a protractor effectively in order to measure off the angle, and then they also need to be able to interpret that. Steps to success for using a protractor: I always say estimate the angle first, because that gets rid of the confusion over the inside or the outside scale. Start off with a horizontal line, put the little cross bit in the right place, mark off the angle, draw a straight line from the center to that angle, to that line, check the answer with your protractor, so forth and so on. Okay, so let's move on. Let's move on to this. So it is your time. So what I would like you to do, and you should have your protractor and everything ready, but if you don't, go off and get it now. I would like you to construct a pie chart. Remember, you could do it on a piece of paper. Nice colour again. No scribbles, please, or dots or hash. Colour it in nicely, please. And also, please remember to then take a picture of it and pop it onto your Word document. Haylock's got a nice quote here: only use pie charts with variables that have a small number of values. For example, the gender of the children in the class, their means of getting to school, their ages in years, the number of goals scored by the school football team for each match in the season. Don't do it when there's a huge amount of data to be looked at. Okay then, so let's move on. And let's move on to some SAT papers. Now, that's a little bit too quick for anyone in Wills. Ian, sorry. So next thing I would like you to do, we've put some SAT papers up on the PowerPoint. We're not going to go through it with you. What we would like you to do is have a go at them and work out what subject knowledge you need to improve on. These are all connected to different types of data, tables, etc, etc. So it's almost like showing you where they will appear in the actual SAT paper. Okay, and we've put up on the top where it's come from, which paper and which year, so you've got an example. Okay, and that brings us to the end of this session. I hope you've enjoyed the first of these, probably many virtual lecture sessions like this. Remember, you need to make sure that you fill out all those, your sheets of paper, your documents, all those questions that we've asked. The PowerPoint is up on Moodle, so you can download it yourself if you wish. And then you need to make sure that you submit that piece of paper, that document, by the end of this week. So it's currently Monday the 23rd, so by Friday, please. And yes, we will be checking. Okay, so make sure that you go and have a look at that. I am going to go off now and prepare the whole cohort lecture, which I'm going to share with you as well. We'll probably try to do that live, so make sure you're in the Teams chat. Check your emails for that, because I'll broadcast it live on there. So if you have any questions, please do not hesitate to email me or message me on Teams. In situations like this, the most important thing is to keep that communication up and running. So do touch in and say hello and give us a chat and keep in touch. We really do appreciate that. Okay, don't forget that later on in the week I am going to be doing a live session, just a random session, And we're going to be talking about just general things. You can ask general questions. And I'm going to be teaching you a little bit of BSL sign language. So if you want a revision of the course, or you missed it, then that's a golden opportunity for you to actually join in. So keep a lookout for that. I will broadcast it live to Facebook and YouTube and my webpage. So keep an eye out for that. Okay, until next time, please look after yourselves, stay healthy, maintain social distance, and I will see you all hopefully fit and well when we get back to university. This has been Ian Wilson, digital version, signing out. See ya. Bye. How do I stop this thing? Ah, there we go.